Okay, scholars, here we are. It is chapter 4, lesson 3. Now, we already did dividing polynomials, long division. That was day 1. So this is day 2 because there's a different method that, like I said right here, it's a bit of a hack, but it totally works. You can use just the coefficients of the polynomials to do the same thing with a slightly different process. It's quicker, but you have to learn the steps. Okay, it's like multiply and add, multiply and add, multiply and add. But the point is, I'm going to show you how to do it. There's only one, there is a limitation with this particular method. And that limitation is that you have to have a divisor with a coefficient of 1. Okay, it can only be an x divisor. So if you have an x squared that you want to divide into this, synthetic is not going to work. Okay. So just keep that in mind. The other thing, if you don't have a coefficient of 1, if it's not just a single x, then you need to divide through. Just like when we did completing the square, it can be done. It gets a little messy. So in the meantime, I've written out the steps. These, of course, are in our notebook if you want to print it out and follow along. Otherwise, you can just watch, pause at any time to make sure that you got all the steps. So first, you're going to draw a half box. You're going to put the coefficients of your dividend in order to the right. So when I say a half box, it looks like this. You're just going to do a little, sort of like an upside down divisor thing, and I call that a half box. You're going to put the coefficients in order to the right. So this is x to the third, x squared, x to the 1, and then there's no other term past that. So it's going to be like this. You're going to put -1 because that's the coefficient here. You're going to put 3, leave a little space just here to the right. You're going to put a 1 here for that x. And then since there's no constant, we do need that placeholder of a 0. Okay, so that's what we're going to do to start. Then to the left of this box, you're going to write the factor you're dividing by. So here we're dividing by x minus 2. Now, because our factors, remember, are always written in like x minus a, then a here, or what's doing the dividing, is a positive 2. So positive 2 goes out here to the left of the box. There. Now, what we're going to do, you're going to love this. We're going to bring down the first term. Okay, so I'm going to change colors here. Just going to bring this down. Then I'm going to multiply times the factor. I'm going to write that product under the next number to the right. So I do 2 times -1, and it goes here. Okay, then I'm going to combine this column. So 3 and -2 is now a positive 1. Then I'm going to repeat it over and over again. So I do 2 times 1, and it goes here. Then I combine. Go back. 2 times 3, it goes here. Then I combine. That's it. Now, the coefficients, okay, if the remainder or the last number is a 0, then this is an even factor, and you have a smaller polynomial. Yay. But if it's not 0, okay, this right here, this last number is our remainder. Okay. And these are the coefficients of the smaller polynomial. So this would be like at the top of our division. And here's how it goes. So starting from right to left, each term starts with a constant. So this is like x to the 0. That's our remainder. This is our x to the 1 term. This is our x to the 2 term. This is our x to the 3 term. And so what you're going to do is you're going to write this answer like this. So when I do this big polynomial divided by x minus 2, then the answer, if I did it long division, is equal to, this is the coefficient in front of my x cubed. So it's negative x cubed plus, because this is a positive 1, and that's a 1x squared. And this is going to be a plus 3 goes in front of an x to the 1. I don't have to write that exponent. And then this is my remainder. So remember, your remainder is written over the divisor, and the divisor here is x minus 2. And that, my friends, my student scholars, is the same answer you would get if you did it long division, which is what we did yesterday. So I'm going to do a few more examples of these. Once you get the hang of it, it actually gets a little bit quicker. But just to remind yourselves of the steps, lots of words, but here's the steps. You bring the first one down, multiply 2 times negative 1, it goes here. Combine these. 3 plus negative 2 is 1. Then 2 times 1 goes here. 1 plus 2 is 3. 2 times 3 goes here. 0 plus 6 is 6. And remember, this is the remainder. If I get a 0, then x minus 2 is a factor of the larger polynomial. If I don't get 0, I just write it with the remainder, just like this, over the divisor. So we're going to do another one. Hopefully you can see that example already in the notebook. Okay. If you have it printed, great. If you don't, you can just put these in your notes as is. So let's remember all of our steps. Okay, so here's our divisor. I have just a single x with the power of 1. This is going to work. Here are my coefficients, x to the third, x squared, x. So I don't even need any placeholders. All right, so I draw my half box, and I put my coefficients. 3, negative 7, positive 6, and 8. Here, I'm dividing by a positive 1 because it's x minus a. So the 1 goes here. First step, bring your 3 down. Second step, 1 times 3 goes here. Then combine. 1 times negative 4 goes here. Then combine. 1 times 2 goes here. Then combine. This is my remainder. Going right to left, this is my x to the 1. This is my x to the 2. This is my x. Nope, sorry, I just messed that up. This is my x to the 0, because that's my constant. That's my x to the 1, and that's my x to the 2. Sorry about that. That is how I sometimes make mistakes, and it's okay. We just fix them. You know how I caught myself? Let me tell you. I know that I'm dividing a cubic by a linear factor. So when I divide 3x to the third by x, I should get an x squared. And that's what I just checked. It's okay. We learn from our mistakes. But here's our answer. Here's our final answer. So when I divide this long polynomial by x minus 1, I get 3x squared minus 4x to the 1 plus 2. And x to the 0, remember, is a constant. That's like a 1. So I don't have to write x to the 0. And then my remainder is 10. So it's plus 10 over the divisor, which is x minus 1. That is my final answer. Okay, again, might be a little confusing. We're doing a couple more examples, and it's okay if you don't get it right away. But I'm telling you, stick with it. You will get it eventually. So let me check. So I've got a 1x. I can use synthetic. Good. I know I'm going to be dividing the number that goes on the outside is a negative 3. Remember, because it's x minus a. So I have an x to the third. I don't have an x squared, so I'm going to need a placeholder. And I have a 1. It's all in order. So I can do my half box. My first coefficient is 2. Then I'll need my x squared coefficient here. So that's going to be a 0. Now I'm going to need a 1 next for my x. And then a minus 11 will go here at the end. My minus 3 goes here. And my first step is to bring down to 2. So let's repeat our steps here. Negative 3 times 2 goes here. Combine. Negative 3 times negative 6 goes here, combine. Negative 3 times 19 goes here, combine. This is my remainder. This is my constant. So this is like my x to the 0, x to the 1, x to the 2. So when I divide this polynomial by x plus 3, my answer is 2x squared minus 6x plus 19, and my remainder is negative 68. So it's minus 68 over the divisor x plus 3. Certainly takes up less room on my page. Let's see if you can do this one. You should be doing this along on your page with me, hopefully by this one. Okay, so again, I've got a 1. It's going to work. X to the 1 and 1, that's going to work. But I'm going to need more placeholders on this, because if it's an x to the 5th, first of all, my answer is going to be an x to the 4th when I divide. Second of all, I'm going to need an x to the 4th. I'm going to need an x squared, and I'm going to need an x. So always got to just check that. Okay, now do my half box. Let's go in order. 2x to the 5th, 2 goes here. X to the 4th, don't have it, so that's going to be a 0. X to the 3rd is going to be negative 4. X squared, don't have it, so it's a 0. X to the 1, don't have it, so it's a 0. And actually, I didn't draw it long enough. 6 goes out here at the end. Here, the divisor is a positive 4, so that goes out here. Remember, our factors are x minus a. So first step, let's bring down our 2. 4 times 2 goes here. 8, combine. 4 times 8 goes here. Combine. 4 times 28. Oh gosh, let me grab my calculator for that one. 4 times 28, that goes here. 112. Combine. 4 times 112. It's getting big now, but that's okay. 448. Combine. 4 times 448. Shoosh. I have all the numbers here. And I combine them, I get 1798. It's a big number, but that's okay. Remember, this is my remainder. This will be my x to the 0, x to the 1, x to the 2, x to the 3. And look, I told you you'd get an x to the 4th as an answer. That's a quartic. And so my answer is going to be, these are the coefficients, these are the powers. 2x to the 4th plus 8x to the 3rd plus 28x squared plus 112x plus 448. Remember, x to the 0 is a 1, so that's a constant. You don't have to write the power. But you do have to write the remainder, 1798, divided by the divisor, which is x minus 4. So ask yourself, how are you feeling about this now? This is synthetic. This, as a long division problem, would have been a lot bigger. But hopefully by now these examples will get you through. We will be doing some more, clearly, and there's more examples in your OneNote. You decide which one you like. Again, synthetic doesn't always work, but when it does, it's beautiful. So I hope you share my enthusiasm, and I look forward to doing these with you in person as well.